Welcome. In this demonstration, we present how you can implement smart city use cases using our data management platform for the IoT, NebulaStream. To do so, we first highlight NebulaStream Smart City, an interactive smart city simulation that produces sensor data streams which NebulaStream ingests. In addition, NebulaStream can actively interact with NebulaStream Smart City via user-defined actuation queries. Secondly, we demonstrate how you can use our user interface, NebulaStream UI, to manage various aspects of NebulaStream, ranging from query submission to result visualization. Enjoy. NebulaStream Smart City runs in a browser and contains various sensors that produce continuous data streams. These sensors are embedded in real-world IoT applications. There's an energy application, which includes wind turbines that, depending on the current speed of the wind, produce energy. Similarly, groups of solar panels, depending on the current position of the sun, also produce energy. In contrast, cars or electric vehicles that move around, households, as well as factories, and also streetlights which turn on at night, consume energy. Two hospitals, which are located in NebulaStream Smart City, are embedded in an e-health application. Patients enter these hospitals, where they are treated, and, on recuperation, leave the hospital again. All sensors in NebulaStream Smart City send their data to NES worker nodes, which are located throughout the city. For example, this hospital sends anonymous patient data to this NES worker node, where the data can be processed locally. All data that cannot be processed locally is sent to a central cloud building. This is also where the NES coordinator resides. If you want to interact with the city, you can use the control menu, for example, to set the current time of the day or to completely freeze the city in a certain state. Furthermore, you can submit actuation queries to NebulaStream that affect the city. Let's assume a company wants to monitor the relationship between the accumulated produced power of all wind turbines and solar panels and the accumulated consumed power of all electric vehicles, households, factories, and streetlights. In other words, the relationship between the overall produced and the overall consumed power in the smart city. Based on this relationship, an actuation query can then intelligently control the number of active streetlights. For example, at night, where only wind power is available, low wind speeds can lead to power shortages. To counteract, an actuation query can reduce the number of active streetlights to reduce the overall consumed power. It can also do so in several stages. So, in this way, you as a user can shape the IoT applications to your likings. In the following, we will show you how you can use our UI to set up a smart energy IoT application for NebulaStream.
After having explored the smart city, we can now turn to NebulaStream's user interface, where we're currently on the landing page. Here you're having an overview of all the subpages, as well as a short summary of what is happening in NebulaStream currently. For example, there are 2 queries registered or 4 nodes in the topology. Let's take a closer look at the topology. Here you can explore NebulaStream's current topology. We created this topology to reflect the application scenario implemented in the smart city. These are the worker nodes that collect data from the different producers. So, for example, this worker node collects data from the consumers, such as the streetlights. This worker node collects data from the solar panels, and this worker node collects data from the wind turbines. The worker nodes process the data and forward it to the coordinator, where, depending on the query, the data might also be processed further until it is forwarded to the user interface. We also provide an overview of the currently registered logical sources in NebulaStream, as well as a detailed look into the field names and also the data types. We already prepared 2 queries here, and we're going to take a look at one of them. The basic idea behind this query is that we're collecting data from the wind turbines, combining that with data that we collected from the solar panels, and over a 1-hour window, summing up the produced power from both of those sources, to then later be able to compare the produced power with the consumed power over the same time interval from the consumers. We're using a join. We can also take a look at the query plan, which is a bottom-up data flow graph where the nodes denote operations that are performed on the data and the edges denote the data flow. So here actually we're looking at the wind turbines and the solar panels as the sources. We're uniting them with a union, and then we're applying the summation with the help of an aggregation. On the other side, we're having the consumers. For the consumers, we're just using an aggregation on the consumed power field, and then we're combining both of them in a join, and finally outputting the data in a sink to be forwarded to the UI. Finally, we can explore the data that has been produced by the smart city and was then processed by NebulaStream in our user interface. In blue, we can see the consumed power, and in orange, we can see the produced power. This could be very interesting for a company that wants to know the relationship between the produced and the consumed power, and in case of a demand and supply mismatch, wants to make the decision to turn off consumers. In the smart city, this could, for example, mean that we're just turning off some street lights. Also, if you were wondering why this graph is moving so fast, despite the fact that we're applying a 1-hour window in our query, this is happening due to settings in the smart city. As currently 1 hour approximately equals 2 seconds in the real world. Thank you for watching the video. I hope you enjoyed it.